work through 5 or 6 more problems today. How do you know if it's an optimization problem or not? Max or min, greatest or least, smallest or largest, something like that is what you're looking for. All right, sir? Thank you very much. Do you want lunch today, sir? All right. We do have donuts. Courtesy of Ms. Johnson. All right. So if it says max or min, we know we're looking for optimization problems. So let's read the problem. Notice I haven't given you a set of rules on how to solve these yet because y'all have shown that you really don't need a set of rules. But basically, we're looking for a couple of equations and find one, take the derivative, set it equal to 0, and move on from there. So let's look at this problem. A manufacturer wants to design an open box that has a square base and a surface area of 108 square inches. What dimensions will produce a maximum volume? So what are we trying to maximize here? Volume. The volume of this box that we have the picture of here. So the question is, how do I find the volume of a box? Length times width times height. Very good. It's three-dimensional. The length times width times height. Now, that means I've got, besides the volume, I've got 3 variables. Well, then we really want to get that down to 1 in order to make this easy on us, if possible. So, anything we can do to get that down to less variables?
X squared 8.
Yes, because the length and width, since the box is square base, the length and width are both the same, so we can get it down to x squared h just from information in the problem. Okay? Now, how can we get rid of the h or get rid of the x? That's right. We need to find another equation which is given to us in this picture because I gave you the picture. Does anybody remember what I was calling that equation? It's a constraint, something that is a constraint equation, something that says this is a maximum on it, okay? And the constraint here is the surface area has to be 108 square inches. So now you have to think about what does surface area mean. Notice it says a box, an open box. Doesn't have a top on it, okay? So we want an open box with a surface area of 108. How do we find the surface area of something? The surface area is the area of all the surfaces. So if it doesn't have a top, it's got 5 surfaces. So it's the area of the bottom, which is x squared, plus, what's the area of this front face here? How do I find it? Length times width, which is x times h, and all 4 of them have the same surface area. All 4 of the sides do, because the length is x, the length is x and the height is h both times. So x squared plus 4xh, that has to equal 108. So now once we have that, that's our constraint equation. Can we solve that equation for x? How? Yes. Solving it for x becomes very difficult because to solve it for x, you've got to use a quadratic equation, and that's just not going to be pretty at all. Bless you. But we can solve it for h relatively easy. So that would be the right thing to do. We'll solve this for h. We get 108 minus x squared all over 4x. And now we can substitute that back into our volume equation. So now we can say our volume is x squared times 108 minus x squared over 4x. Once we get it down to just 2 variables, V equals something that's just got x's. We know we're going to take the derivative, set it equal to 0. Do you want to do any algebra before you take the derivative to that? Okay, what do you want to do, Kevin? All right, Kevin says he wants to cancel out an x. I assume you mean this x in the denominator? And that right there? Okay, so let's see. We can say V is x times 108 minus x squared over 4. What do you... But this one's not divisible by 4. Yeah, both of them have to be, yeah. Do you want to do any other algebra? Okay, you want to just treat it like it is. It's fine to do that. Okay. Good question. Could we multiply the x through? Yes, we could multiply it through. I would recommend, let me ask you, when you try to solve this one here, what would you, if you're going to take the derivative just like it's written, what are you going to do? Product rule, first derivative, second derivative, first, and you might even see a quotient rule over here, and that just doesn't sound fun at all. So I would go ahead and distribute and get 108x minus x cubed over 4. So now we don't have a product rule anymore. We've just maybe look at it that we've got a quotient rule. Can anybody see how we could even get rid of the quotient rule there? How could we do that? Can't multiply it by 4 because that would mean we'd have to multiply this by 4. But we could do this. We could factor out a 1/4. 108x minus x cubed. And see, by doing that, you say, well, we're back to a product rule. But what's the derivative of 1/4? 0. So we really don't have a product rule. So now, this is the easiest way, I think, to take the derivative. You could have taken the derivative back up here at the original one that I had in black. At any step along the way, you could have taken it. I think if you do it down to here, it's an easier problem. So now V prime becomes 1/4 times 108 minus x squared. Okay? 108 minus x squared. So set it equal to 0. Oh, you're right. Thank you. 3x squared. Thank you. Minus 3x squared. That will make life much easier for us also. Well, the 1/4 is never equal to 0, so we can kind of throw it away. 108 equals 3x squared. X squared equals 36. So x equals plus or minus 6. In this case, it's going to be a positive 6 because negative 6 wouldn't make any sense. So we have a 6. Do we need to test to be sure that whether it's a max or a min? You can. Most of the time in these problems, we're not going to ask you to justify it, bless you. But you're more than welcome to do a sign line and determine that whether or not it is a max or a min. So it's a 6. Our factors were 1/4 and 108 minus 3x squared. The 1/4 is always positive. For a number less than 6, maybe 5. 5 squared is 25, 75, 108 minus that's a positive. That means the function is going up, the volume's increasing. A number bigger than 6, maybe 10, is 300, that's negative. So indeed, this is a maximum. So if we make this box 6 by 6 on the bottom, it will be the right size to give us maximum volume at 100 square inches, 108 square inches. It asks for the dimensions. What does that mean? You got to know the height too. Very good. So we know that x equals 6. H is what? 108 minus x squared over 4x. 108 minus 36 over 24. Am I doing that close to right? Afraid so. Yes, I am. What's that? 72? 72 divided by 24? 3. So 6 by 6 by 3. The dimensions of my box are 6 by 6 by 3. Do you see any validity in something like this in real life? Being able to do this? If so, what? That's right. Or think about it even bigger picture. He said something that will make the largest container with a specific amount of material. What if you're trying to make a box the right size for the least amount of money? Or maybe we're concerned with shipping this thing. Sometimes when you ship things, you have to measure the length, width, and height. And based on the length, width, and height, the charges, they might decide how much they're going to charge you to ship it. Now, sometimes they look at the weight as well. So those are the type questions that might be big picture things that would be very beneficial to have in a business industry. Yes, sir. Sure.
Just back up near the beginning.
Okay.
I'm trying to figure out where the X came out on H.
Right here. So we had x squared times the height, so we were able to cancel one of these x's with that one there. And then we multiplied that back through. You with us, sir? All right. Any questions about this one? All right. Now, this one's a little more mathy than what we would normally work with. Which points on the graph are closest to 0, 2? What does closest imply? Minimum, okay? What are we trying to minimize?
The distance between those two.
Okay. So this is just another way of saying we want to minimize the distance. Well, how are we going to do that?
Oh, this formula. Square root x2 minus x squared. No, that's y2 minus y1.
Very good. Y'all remember that from anywhere? Okay. If you square both sides of it, it looks like something that you've seen before. If you were to square both sides, you'd have d squared equals x2 minus x1 squared plus y2 minus y1 squared. What does that kind of look like to you? Pythagorean theorem, okay? So that's the distance formula. This is finding the distance between 2 points. Okay? So if we want to find the distance between this point and this point, we can put in the coordinates of it into that formula, which is derived from the Pythagorean theorem, and get an answer. All right, well, let's do that. D equals the square root of, let's let x2 be just plain old x minus 0 squared plus y minus 2 squared. All right? Well, we've got d's, x's, and y's. See any way to clean that up even more? Can we get rid of the x's or the y's in any way? Some say. Then we have a huge problem.
Y equals 4 minus x squared.
Okay. What has to be special about this point xy? It has to be on this curve. So y has to be equal to 4x squared. So suddenly we can do something with this y. We can say it is the square root of x squared plus 4 minus x squared minus 2 quantity squared. All right, so the minus 0 I just dropped off because that makes sense to me. Can we do some more cleaning up before we have to do something here? Yes, we can clean it up a little bit more and say D equals the square root of x squared plus 2 minus x squared squared. You could square that thing out under there. I don't know that I would go to the trouble of doing that just yet, but you could if you wanted to. At this point, I'd take the derivative and set it equal to 0. Talk to me about taking the derivative of this. What do you have to do? Chain rule. So it's going to be 1/2 this mess to the negative 1/2. Now, what's the derivative of the inside stuff? 2x plus, how are we going to take the derivative of 2 minus x squared quantity squared? Chain rule again. 2 minus x squared to the first times a negative 2x, right? Boy, wasn't that fun. So let's clean that up a little bit more, okay? D prime. Can everybody look at that and tell me it's going to be a fraction? We're going to have, do you see that this term right here is going to be a square root that we can put in the denominator? So I'm going to put this 2 from the 1/2 in the denominator. I'm going to put this square root in the denominator. Okay. And the top, I've got 2x plus 2 times 2 minus x squared times negative 2x. We can multiply some stuff through there, I think. That becomes 2x plus negative 4x times 2 minus x squared over that same stuff. I'm not going to keep writing it. We could distribute this thing here and get 2x minus 8x plus 4x squared cubed. Cube. All right? Over 2 and all that stuff. What else could we do? Oh, we could combine the first two things together, couldn't we? Negative 6x plus 4x cubed over 2 and all that stuff. We can pull a 2 out even. How about that? So we could say, let's pull out a 2 and make it negative 3x plus 2x cubed over 2 and all that stuff. So we could cancel the 2's. Over, now write that stuff back in there. X squared plus 2 minus x squared squared. That's about as clean as we can get it. And we need to be concerned with, yes, I got that right, when that's equal to 0 or undefined. Agree with that? So, it's undefined. Say that again? It's never undefined. Okay? Because we're squaring a number with this x, so it's got to be 0 is the smallest it can ever be, and 2 minus 0 is going to be positive, so it's never undefined. So all we got to worry about is the top.
If it was undefined in some problem like this, would it be on the line?
What would you say that again? Yes, I think you're correct there. So now we can say 2x cubed minus 3x equals 0. Very good. We need to factor out a 0. 2x squared minus 3 equals 0. And we get x equals 0 and x equals plus or minus the square root of 3/2. Now we got 3 answers. Not all, yeah, but how is this different from other problems we've worked so far? Most of the time we've only gotten 1. So we've got 3 answers here. We're trying to determine which one's closest. So how do you want to determine which one's closest? You've really got a couple of options here. Huh? Good question. Do you know that two of them are going to be closest? Yes. It's either going to be this one or it's going to be 2. So you know that either that's right or these two are right, pretty much. Exactly. You've got a couple options. You could put 0 in here. Well, you'd actually you want to minimize the distance. So you could put 0 back in here, put them both into here, and find out the distances. That's one thing you could do. Because you don't want to minimize y, you want to minimize the distance. So we could find out that it's 0, 4, and whatever those other numbers are, plug them in here and find the distances. Or we could come down here and just simply do a center line of the distance. We've got 0, the square root of 3/2, and the negative square root of 3/2. Okay? And if we're doing that, then we've got, what have we got? 2x cubed minus 3 was the numerator. And then we've got the denominator, 1 over the square root of x squared plus 2 minus x squared, quantity squared. We know it's always positive, so it's really not going to have any bearing on us. Would you agree with that? Now, where's the number 1 in relation to the square root of 3/2? To the left of it or to the right of it? Where's 1 at? Is 1 in here or is 1 over here? Yes, 1's over here. So let's plug 1 in here. 1 cubed is 1. Oh, it's that, yeah. 1 is 2 minus 3, so that's going to be negative. So the function is decreasing from 0 to there. What happens if we put, what's a number bigger than square root of 3/2? 4. Okay. 4 cubed is 64, is 128 minus 12. That's obviously a positive number. So what does it look like for square root of 3/2? This looks like a minimum to me, doesn't it? That's what we're trying to do. We're trying to minimize it. All right, let's go back to see what happens if I put negative 1 in here. I get negative 2 and positive 3, right? So it's plus. So what about this distance here? That's a max right there. Wow. So this is the maximum distance. Wow, that doesn't make a lot of sense, does it? Positive to negative. All right, what about negative 4? When we put that in there, negative 4, we get negative 128 plus something, so we get negative here. So this is back to being a minimum. So we got 2 minimums. Does that 0 in there being a maximum bother you? It doesn't? Is it the absolute maximum? Okay, yeah, I would agree. It's, okay. What was bothering me to begin with is that's not the absolute maximum. Would y'all agree with that? Because, I mean, you know when you get way down here somewhere, that's further away than that little distance up there. But it is the largest in the region, because think about what the distance is doing. The distance is going down, then it's going up, then it's going down, then it's going up. So it's going to kind of look like a W in there. Just what the distance is going to look like. But we found our minimums. There's 2 of them. It's root 3 over 2 and negative root 3 over 2. Okay? All right, let's find something that'll wake y'all up this morning. I don't want to do the square and the circle. The sum of the perimeters of an equilateral triangle and a square is 10. Find the dimensions of the triangle and square that produce a minimum total area. That's a nice problem for y'all to ponder on for a moment. See if you can get some equations written down, and then we'll talk about if they're right or not, okay? All right, how are you today? They are two separate things. They're not connected necessarily. Yeah. Is the side of the triangle and the side of the square the same length? We don't know.
My equation is 3x.
So you said that's x and this is y, so you said 3x plus 4y equals 10. What do y'all think?
I'm not sure about equilateral triangle in general.
All right, that is correct. Equilateral, y'all remember that equilateral means all the sides are the same. Square means all the sides are the same, okay? Find the dimensions of the triangle and the square that produce a minimum total area.
Then you do the area equation.
All right, so what's the area of a square? Of this square? Y squared.
And then you add the area of the triangle.
Yeah. What's the area of an equilateral triangle? Okay, what's the height?
Well, then you can draw it.
You could, yes. You could come in here and say, remember, if this is equilateral, do we know how big that angle is there? 60. Okay, so if that's 60, and we draw a height in here, that's 90. So how big is this angle up here? 30. Does that bring back any memories, be them good or bad? It's a 30, 60, 90 triangle. And we know the hypotenuse is x. So what do we know about the long side? Anybody remember that? 1, 2, the square root of 3. It's root 3x tall. So it's base x times height root 3x over 2.
Is x in with the square root?
No, x is not in with the square root. I told you that wrong. That's root 3 over 2. I'm sorry. That's root 3 over, the height is root 3 over 2. Because this side right here is x over 2. It's half of it. And this side here is twice as long, the hypotenuse is twice as long as that, and the height is root 3 as long as the short side. So you can wind up with this, root 3 over 4x squared. That's your area. It's y squared plus root 3 over 4x squared. Y'all agree with that? Why 4? Because the height of this triangle is root 3 over 2x, not root 3x. Okay? And let me draw it out because I kind of botched that up. We know that this is x. This side, the short side, is half of that, which is x over 2. And this side over here is the square root of 3 times as long as the short side, which is x over 2. If you go back and remember those things from 30, 60, 90 triangle. If you don't remember that, you know this is a 60-degree angle, right? So then the sine of 60 equals the opposite side, which we don't know, over the hypotenuse, which is x. So the hypotenuse is x times the sine of 60. And if you go and figure out what the sine of 60 is, the sine of 60 is root 3 over 2. Or you just memorize that an equilateral triangle has that formula. Any of those ways will get you there. So we've got our area. It's ugly. It's an ugly formula, but we have it nonetheless. We have our constraint. Are you going to solve the constraint for x or for y? Either one will work, but looking at them, does one look like it'll help out more or make life easier, or is it just going to be ugly no matter what?
Well, guessing one's a lot easier because solving for y is very annoying.
Solving for y up here is very annoying.
No, you solve for x.
If you solve for x up here, then you're going to have
A number to plug into
10 minus 4y over 3 putting in here. That's not going to be real pretty, but at least that one over there is going to be pretty. I don't think it makes a whole lot of difference. Either way is going to be slightly painful. Okay, so if we solve that for y up here, we get y equals 10 minus 3x over 4. So if we plug it in down here, but now we've got to square that mess. Well, we can take the we can take a derivative with the chain rule. Yeah, you're right. We're going to have to square it either way. 10 minus 3x over 4 squared plus root 3 over 4 x squared. Now, I'm going to write down a couple other things that I think makes life a little bit easier here. Do you agree with that I just wrote down? 10 minus 3x quantity squared over 4 squared? Okay. That's just taking this squared and distributing it to the numerator and the denominator. And I'm doing that because then I can make my area 1/16 times this thing here. Now it's a little, I don't even see a quotient rule in there anywhere. So now I can take my derivative. I get 1/16 of 2 times this ugly stuff times negative 3 plus 2 root 3 over 4x. And I bet y'all can finish that off. It's not going to be pretty to deal with, but it can be done there. We get negative 6d plus 18x over 16 plus root 3 over 2 plus root 3x over 2. All of that equals 0. How would you go about solving that ugly thing? What's the next thing you would do, anyone? Set the denominators to the same thing, or get a common denominator? Yes, you can get a common denominator now, and that's negative 60 plus 18x over 16 equals, it doesn't equal anything yet, plus 8 root 3x over 16 equals 0. So now I can throw the denominators away. Would y'all agree with that? Multiply everybody by 16. So now I just have 18x plus 8 root 3x equals 60. So x is 60 divided by 18 plus 8 root 3. Now, I did a lot in my head, so please don't hesitate to say, what? When I threw the denominators away, I then took the negative 60 to the other side, making it positive. And then moving to this last step, I just factored an x out in my head and got that ugly number there. So that's the length of the equilateral triangle. and we could figure out the length of the square here. Everybody comfortable with that? What were we trying to accomplish here? We were trying to minimize the area, right? Is this, in fact, going to be a minimum? Let's see. There's that number. Anybody got any idea about what that is? About what it is? Square root of 3 is about 2, is a little less than 2. 2 times 8 is 16. 18 and 16 is 32. So it's a little less than 2. Would you agree with that? All right, so what happens when we put 1 into this area derivative right here? What happens when we put 1 into our area derivative here? We get 10 minus 3 is 7. 7 times negative 6 is negative 42 over 16, which is negative 2 point something. Would y'all agree with that? If we put 1 in here, that's going to be smaller than 1, so we get a negative. What's a number bigger than that? 10. 10's a nice number to work with here. 10 minus 30 is negative 20. It's going to be a positive number. That's going to be positive. So it is indeed a minimum. That will give you the minimal area there. Yes.
Are they going to be tricky?
Oh, yes. Oh, yes.
Decide if they're going to use
We have an FRQ coming up in January, I think, when you determine when the best time is to go to the amusement park. The best time of day. You want to go see if it actually works out. There is. It's after y'all. It's after the seniors are out of school. So I don't know if y'all would want to come back for that or not. Okay, one last problem today. Yes, we're not going to go with it. One last problem that I want us to work together, because this is a nice problem. This problem there's recently been a lot of uproar over this problem, or a problem very similar to this, because it was on a middle school math test in Singapore, and they thought it might be a little bit too hard for them. Very similar to this. The concept's the same here. No, they didn't get it right. So that was and I agree. I think it's a little too difficult, because I don't know how you solve it without calculus very easily. An offshore oil well is 2 kilometers off the coast. The refinery is 4 kilometers down the coast. Laying pipe in the ocean is twice as expensive as on land. What path should the pipe follow in order to minimize the cost? Okay. So, here's our shore. Okay. Here's the refinery. That is where they're going to take the oil and turn it into gasoline. Okay. And here is our oil rig out here.
What are the possible, can you do, are the possible paths like just straight to the shore and straight down?
Oh, no, you could do anything you wanted here.
Sir,
Yes, sir.
it would be cheaper if you have it go to the coast than down to the refinery.
Okay. So, one obvious thing we could do is we could put pipe from here to here, and then from here to here. Agreed? Another possibility would be to go to here, just straight to it. Okay? But we could do anything in between also. Now, if we're trying to minimize distance, which one do we do? through the hypotenuse. Shortest distance between 2 points is a straight line. What path should the pipe follow in order to minimize the cost? Because we're in business to make money. So we really don't care how much pipe we lay as long as we minimize the cost of laying the pipe. So, is it cheaper to do something else? Well, how are we going to figure that out? We need to minimize the cost. So how are you going to figure out the cost? This is 2 and this is 4. I'm sorry. How are we going to minimize the cost?
Well, 2x to go in the water and just x to the pump.
Okay, so the cost is 2 times the water, pipe that's in the water, plus $1 times the pipe that's on land. Okay? So 2x plus y.
The cost of x and y is the same. It seems like it changed.
Yeah,
Wouldn't it be 2x plus y?
2x plus x.
Sorry, 2x plus x.
Okay, let's go back and read it. So, laying pipe in the ocean is twice as expensive as on land. So the x in my problem here is the amount in water. Okay. I'm going to change that because yes, I'm with you there. X is the amount on land. And y is the amount of pipe in water. Right. The length of it, okay? Amount or length. That's right. And you say, we don't know the price of it. We don't really need to know because we know that it's twice as expensive. So if it's $1 million on land, it's $2 million in the water. It's going to wind up being the same thing there. So we'll just use 1 and 2. So we've got 2y plus x. Well, what's the relation? Yes, sir.
Shouldn't x be the amount on land and then it just be 2x is the amount on water?
No.
X is how long the pipe is on land.
Okay.
And y is how long the pipe is in the water.
There's only one.
So this is going to be x, and this is going to be y.
Well, either it's cheaper to go straight to the land and then down, or it's cheaper to go straight to the oil.
So you think it's going to be cheaper to either go here or go like that. You don't think it's going to be cheaper to do what I've done in blue. Well, what's it going to cost to do this? I mean, for this, it's going to cost $8. In small numbers, that's going to be $8, right? Because it's $2 for every 2 times 2 plus 4 times 1 is $8.
If you were going to compress the water, it would be $8.94.
No, it's going to be 4 squared. 4 squared is 16 plus 2 squared is 4. So it's the square root of 20.
Which is approximately 8.94.
Wait a minute, no. It's 4 squared and 4 squared, isn't it?
No,
No, okay, yeah, I'm looking for the distance here. So it's the square root of 20 times 2. Yes, because that's the length. So it's 2 root 20.
Which is
$8.94, okay? All right, so I think I can figure a blue that's going to be less than that. I think I can figure out a blue that's going to be less money than either of those. Okay? How do we get $8.94? We figured out that this distance right here, the distance is the square root of 20. And the cost for laying it in here is twice as much, so 2 times the square root of 20. The square root of 20 is 4 point something. So, yeah, 4 point something.
4.47.
So 2 times that would be $8.94. So I think we can figure out something better than that. So, our problem is we've got x's and y's in here. I want to get rid of that y. How can I do that?
I mean, it's still an a squared, b squared, and c squared, right?
Where do you see a squared and b squared and c squared?
Is that only for right angles, or is that
Yeah, that only works for right angles. How can I figure out what y is? Look at this. Look at that triangle right there with the black dots. Well, we don't really know because it's changing there. But how long is this piece right there? Can anybody tell me how long that piece is? I think you can give me an expression for it. You can't tell me a number, but what's the expression, Chase? You're exactly right. Now, I want an expression in terms of x. I want to know what that black line is with an x in it instead of a y. 4 minus x. Do y'all buy that? Nothing wrong with what Chase said there. He's exactly right. But we could also say that's 4 minus x. Because this whole distance is 4. That piece is x, so that's 4 minus x. So now, come down here and we can say y squared equals 2 squared plus 4 minus x squared. Right? Well, then what's y must be the square root of that mess. So let's figure out what our cost is now. Our cost is 2 times the square root of this. And actually, since that's just a square, I'm going to go ahead and square it out. Square the front, square the back, twice the product of the 2 plus x. 2 times the square root of 4 plus 16 minus 8x minus x squared. So the cost is 2 times 20 minus 8x plus x squared plus x. There's the cost.
Can you get that in squares using the...
This hit, I don't think 10 and 2, 5 and 4. It's got to be a positive 20. So we need to take the derivative now, don't we? So our derivative is 2 times 1/2 times this mess to the negative 1/2 times negative 8 plus 2x, because I took the derivative of the inside. All of this plus a 1 because of this plus x outside of it. Well, let's write that up as a fraction here. So C prime is, does everybody agree that the 2.5 will go away? So we've got 2x minus 8 in the top. Got this ugly square root in the bottom. Plus 1 equals 0. Amen.
Well, if you give them a common denominator, don't they cancel out?
If you give them a common denominator, yes. What I would recommend doing, and I'm going to do the same thing, it just makes a little more sense to me to do this. If I move the 1 to the other side and cross multiply, I accomplish the same thing, but I don't have to think about fractions there. It's easier to me to not have to think about fractions. Over this square root equals negative 1. So 2x minus 8 equals negative square root of this. You buy that? Well, now what are we going to do? If we do that, we're not going to get anywhere. We've already set it equal to 0 and moved to here. And it's not going to do us any good. How can we get rid of the square root? If we square both sides. See how much fun we're having now? Square the front. Square the back. Twice the product of the two. Equals. When we square this, the negative goes away and the square root goes away. This is probably one of the hardest problems I've ever seen. From a mathematical perspective, it is. You with me? So just stay with me. Let's finish this thing off here. We're going to get 3x squared minus 24x. I'm taking these things over. Subtract. Plus 44 equals 0. I would not think that that's going to factor at all. So I'm going to do plus or minus negative b. Oh, I don't want to type. 24 plus or minus the square root of 24 squared minus 4 times 3 times 44. Somebody's got to have calculating devices for us. $496 minus 4 times 3 is 12 times 44 is a big old number. Oh, 176 times 3 is like 5 something. I hope that's wrong. Isn't it? I don't think 496 is right. 24 times 24. 25. You got 5 point who? 15. That's for the plus one. What about for the minus one? 576, okay. All right, so what did you get for this 4 times 3 times 12?
144.
No.
Wait, no, you said
I did, yeah. Yeah, 4 times 3 times 44, my bad.
528.
Over 6. So now if we do 24 plus or minus 50. So you got 5.15 one time, and what'd you get the other time?
Wait, no, the 4 times 24, the 4 times 3 times 44 wasn't 526, it was 528.
Okay. 528, which makes this number here 48 then?
Yeah.
And we got 5.15 and 2.85. So now do you understand what this is saying here? There's a critical point when x is 2.85. What was x back up here in our picture a long time ago? This distance here, 2.85. So if we go 2.85 right here along the coast, and then the rest of the way, that's the least expensive way to lay that pipe. Or, what was the other one was 5 something, right? 5.15. Where would 5.15 be? Be over here somewhere. Do you think that's going to be a minimum way to go over here and then down? So, and you'd have to do the sign line. I'm too lazy to do the sign line right now. But if you were to do the sign line, you'd find out that if you laid 2.85 miles of pipe here, and whatever it takes there to get to the oil rig, you'll save money. Do you think that's important for companies? Yes. All right. I'm old, so I lose track of time, so y'all may not even realize this. Do y'all realize that several years ago, the airlines reduced the number of peanuts? This was a long time ago because there's not even peanuts on airlines anymore. But they reduced the number of peanuts in each package by 2. Do you know why?
Seems like a lot of money.
Save them millions of dollars a year by taking 2 peanuts out of every package. Does that make sense? Does that make any sense? I mean, if you know, I mean, if you're sitting there thinking I paid $500 for this seat and they just took 2 peanuts away from me so they could save money, it doesn't sound like a lot. But you think about the mathematics that we just poured into this. Don't you think that they probably would want mathematicians, somebody that can figure those things out to say, hey, I just saved you $10 million by taking 2 peanuts away from everybody. Nobody's really going to notice 2 peanuts. Now, if the media... Yeah, but I mean, you know, there's not going to be a noticeable difference in that. I don't know if y'all realize it.